Today, we are going to discuss operations on sets. In arithmetic, we know that there are four basic operations, such as addition, subtraction, multiplication, and division. We can perform similar operations on sets. So these operations are union, intersection, complement, and difference. So the union of sets A and B is a set of all elements which belongs to A or to B or to both. So we write A union B, A U B, and say A union B. So the symbol of union is letter U. So let's now have properties of the union. So let A, B, and C be three sets. Then the following statements are true. Number one, A union A is equal to A. That is idempotent law. Number two, A union B equals B union A. That is from the commutative property. Number three, A union the quantity of B union C is equal to the quantity of A union B union C by virtue of associative property. And number four, we have A union empty is equal to A. And the other one, the last one, A union universal is equal to universal set. So let us have an example. Number one, if A is a set of 2, 3, 4, 5, B whose elements are 4, 5, 6, 7, set C whose elements are 6, 7, 8, 9, and set D whose elements are 8, 9, 10, and 11. So we find first A union B. So A union B equals, so A whose elements of A are 2, 3, 4, 5. Then union B, we have 4, 5, 6, 7. So to solve for that, so we are just going to combine all the elements such as this. So we have now A union B whose elements now are 2, 3, 4, 5, and we combine this the other from the set B. So we have 4, 5, 6, 7, but 4 and 5 is already present or found in the set A. So therefore, we will just write the remaining elements. We have 6 and 7. So therefore, A union B whose elements are 2, 3, 4, 5, 6, and 7. So that's very simple. So let's continue with letter B. We have A union C. So I will write first the elements under A, set A. We have 2, 3, 4, 5. Union C, we have 6, 7, 8, and 9. So combining the two sets of A and C, we have A union C. Therefore, we have 2, 3, 4, 5, 6, 7, 8, 9. For B union C, we have B is whose elements are 4, 5, 6, 7. Union whose elements of C are 6, 7, 8, 9. So just a matter of combining all the elements now. For between B and C, we have now 4, 5, 6, 7. So 6 and 7 is already present in the set B. Therefore, we will just write only 8 and 9. So we have 8 and 9. So B union C is 4, 5, 6, 7, 8, and 9. Then for B union D, we have B is 4, 5, 6, 7. Union set D, we have 8, 9, 10, 11. So up to 11 only. So therefore, let's combine all the elements found in B and D. So therefore, we have 4, 5, 6, 7. Then we also have 8, 9, 10, and 11. So that's the answer now for B union D. And for letter E, we have the quantity of A union B. So we have already the answer for A union B, which is this one. So I'll copy that one here. So A union B is 2, 3, 4, 5, 6, and 7. And then union C, which is now 6, 7, 8, and 9. So combining this one, so we have now the set whose elements are 2, 3, 4, 5, 6, 7. Then we have 6, 7 here, so no need to write because it's already present in this set. The other elements we have 8 and 9. And for this one, for letter F, we have A union the quantity of B union C. So let's try to write first the set of A. We have A is 2, 3, 4, and 5. And then B union C, we have now the answer a while ago. I'll just copy that one. And we have here union, the quantity of B union C, which is now whose elements are 4, 5, 6, 7, 8, 9. So combining this one as A union, the quantity of B union C, therefore the sets now are composed of 2, 3, 4, 5. We have 4, 5 is already present on the set A, so no need to write 4 and 5 again. So the remaining elements now are 6 up to 9. So 6, 7, 8, 9. As you can see, for letter E and F, examples E and F, so we have the same answer. It's because from the given, we can use the associative property. Now for letter G, we have set B whose elements are 4, 5, 6, and 7. And union, the quantity of C union D. But C union D we don't have yet. So we don't have C union D. So let's try to add a answer for C union D. So C is 6, 7, 8, 9. So I have 6, 7, 8, 9. So combining set C and D, we have 8 and 9 is already present here in the set C. Therefore, the other elements are 10 and 11. So therefore, C union D, we have 6, 7, 8, 9, 10, and 11. So I will use that answer now to complete the answer for letter G. So we have now here C union D, which is now 6, 7, 8, 9, 10, and 11. So taking the union of these two sets, this will be now whose elements are 4, 5, 6, 7. So 6 and 7 will not be written anymore because it's already present here. Therefore, the other elements are, we have 8, 9, 10, and 11. So that's the answer now for letter G. Now let's move on to the definition of intersection. So the intersection of two sets A and B is a set of all elements that are in both A and B. So meaning to say the common between the two elements. So we write A intersection B. This is a symbol of inverted U. Inverted U is the symbol for intersection. So write A intersection B or say A intersection B. So these are the following properties of the intersection of sets. So we have let A, B, and C be three sets, then the following statements are true. So number one, A intersection A equals A, that is coming from the idempotent law. Number two, A intersection B equals B intersection A, that is from commutative property. And number three, A intersection the quantity of B intersection C is equal to the quantity of A intersection B intersection C. That is from the associative property. At number 4 and 5, they are the idempotent law. We have A intersection empty. So there's no intersection between the two. Therefore, that is now empty. But the other one is A intersection universal is equal to A. So we also have rules regarding the distributive laws. For any three sets A, B, and C, the following statements are true. So intersection is distributive over union from the left and the right. So this is what I'm trying to say. We have A intersection, the quantity of B union C is equal to A intersection B, A intersection B, then we have union A intersection C. That is from this statement. That is, intersection is distributive over union from the left and right. Another example, we have the quantity of A union B intersection C is equal to A intersection C union B intersection C. For number 2, we have union is distributive over intersection from the left and the right. So we have A union, the quantity of B union C is just equal to A union B intersection A union C. And the other one, the quantity of A intersection B union C is equal to A union C intersection B union C. So try to familiarize these distributive laws. Okay, so we have here an example regarding intersection. So if is a set of 4, 6, 8, 10, and 12, and set B whose elements are 8, 10, 12, and 14, set C whose elements are 12, 14, and 16, and set D whose elements are 16 and 18. So find A intersection B. So take note from the word intersection, we are trying to find the elements that are common between the two sets. So I will just write my solutions in detail. So let's try here for A intersection B. I will write first A. We have 4, 6, 8, 10, 12. Intersection B, whose elements are 8, 10, 12, and 14. So what is now common between the two sets? So I have 8 on set A. We also have 8 on set B. So we have also 10 from set A. Another is 10 from the set B. So 12 is present in set A, and 12 is also present in set B. So in that case, the intersection between the two sets of A and B will be now 8, 10, and 12. Okay, I hope you were able to follow. Now let's try again for letter B. We have B intersection C, whose elements of B are 8, 10, 12, 14, and 14. So intersection C, whose elements are 12, 14, 16. All right, so what is common between the two sets of B and C? We have the common is 12 and 14 are common. Therefore, B intersection C, whose elements now are 12 and 14. Okay, so next for letter C, this is now using distributive law, but we will try to write first the set A, whose elements are 4, 6, 8, 10, 12. Then intersection C intersection D. But since I don't have C intersection D, I will try to solve it first here on the others on this side. So we have C intersection D. I have C intersection D. So what is now common between C and D? Let us look at this. So what is the intersection between the sets of C and D? So we have C, we have 12, 14, 16, and D is 16, 18. So the only common between the two is this one. So therefore, I will write C intersection D is the set whose elements is just 16. All right. So therefore, I will write here now the value of C intersection D. So C intersection D, which is whose elements is just 16. And now we're going to find the intersection between these two sets. So what is now common between the two? So I have 4, 6, 8, 10, 12 on set A, and C intersection D is 16. So we cannot see anything that is in common. Therefore, we can just write here as the null set, or empty set or null set are just the same. So these are the two symbols that we are using. Either of the two is the symbol for the empty set. Okay. Then for letter D, I have A intersection C. So we have here A, we have 4, 6, 8, 10, 12. And then intersection C, whose elements of C are 12, 14, and 16. So what is now common between the two? So I guess the common between the two is just 12. So therefore, we have now the answer now for A intersection C is just an element of 12. But you should write that one inside the symbol of a set. Okay? So we have now B intersection D. So B is whose elements are 8, 10, 12, and 14. Intersection D, whose elements of D are 16 and 18. So therefore, what is the intersection between the two? So we cannot see anything that is in common between the two sets. Therefore, this is also empty. Okay, so next, move on to the next letter. We have here A intersection B. Since we already have the answer for A intersection B, which is this one, so I will write now the answer a while ago, which is A intersection B, whose elements are 8, 10, 12. Union C, whose elements of C are 12, 14, 16. Now let's try to answer the operation that is now union between these two sets. So therefore, we're going to combine everything. So we have now 8, 10, 12. So 12 is also present here, but write only once. Then we have 14, 16. So that's the answer for this letter F. Now for letter G, so we have A intersection of the quantity of B union D. So we don't have yet B union D. So I will answer first here. What is our B union D? So we have B union D. So let's combine everything B and D. So start now with set B, whose elements are 8, 10, 12, 14. So, and the other one is set D, D whose elements are 16, 18. So 16, 18. Okay, so that's now the answer for B union D, which we are going to write here for our letter G. So I will write first the set A, whose elements are 4, 6, 8, 10, 12. Intersection B union D. So this is our answer a while ago for B union D. So I will write here 8, 10, 12, 14, 16, and 18. So let's try to find out what is the intersection between these two sets. So we have 8, 10, and 12 here. We also have 8, 10, and 12 here. Therefore, that is now the intersection between these sets. So we have the answer now of 8, 10, 12. Next letter, we have A intersection B. We already have A intersection B, so I will just copy this one again. So A intersection B, whose elements are 8, 10, 12. Union B intersection C, we have this. So I'll write down, I'll copy this one. The answer for our B intersection C, whose elements are 12, 14. So combining the two sets because it's union, so therefore we're gonna combine everything. So we have now 8, 10, 12. So 12 is also present here, but write only once. Then we have 14. And for this, we have A union D. So do we have A union D a while ago? I guess we don't have. So I will write it here. So we have A union D. So combining A and this A and this. So we have 4, 6, 8, 10, 12 plus 16 and 18. So we have 4, 6, 8, 10, 12, and then that's A, right? Okay, then A, then D. We have 16, 18. That is the answer for A union D. So I can write it here. 4, 6, 8, 10, 12, 16, 18. Intersection B union C. Do we have B union C a while ago? So we don't have. So I will write here for B union C. So let's combine B and C. So I'll start now with our B is 8, 10, 12, 14. And combine it with set C. We have 12, 14 is also present. So no need to write 12 and 14. So we have to write now the last element, which is now 16. So this is now the answer for B union C. So I will write here for B union C, whose elements are 8, 10, 12, 14, 16. Now let's try to use the operation involved, which is now the intersection. So let's try to find out what is the intersection between these two sets. So I have 8, 10, 12, 14, 16. So we will check properly. So I have 8, 10, 12. We also have 8, 10, 12. Then I don't have 14 here, but I have 16. It's also is in common. Therefore, our answer for letter I will be whose elements are, we have 8, 10, 12, and 16.